Hi, we are going to talk about the application of minimum spanning tree today. And these are our contents. And now I'm going to talk about the motivation for optimizing power distribution layout. So why power distribution requires optimized network layout? The primary purpose of a power distribution system is to reliably deliver electricity from power sources or substations to end users. And the length and number of distribution lines directly affect construction cost and long-term maintenance costs. And what's more, poor network planning may result in redundant wiring, wasted resources, and an increased risk of system failures. Therefore, reducing the overall wiring cost while ensuring that all nodes are connected becomes an important engineering problem. So we are going to introduce the use of minimum spanning tree algorithm for power distribution network layout planning.
Let's see how we model a power grid. We use graph theory to simplify the system. As you can see, a power grid is made of two main parts: nodes. These represent substations, transformers, or the houses they receive power. Edges. These are the physical power lines connecting everything. By using this model, we can easily see how power flows from the source to the users. A graph is not just lines and dots. We need to add details called weights to make it realistic. These weights represent three key things: length, how far the power needs to travel; cost, how much it costs to build or fix the line; resistance. This helps us calculate how much energy is lost during transmission. In short, these ways turn a simple drawing into a powerful tool for calculation. The most significant advantage of this model is the ability to transform engineering challenges into optimization problems. By representing the grid as a graph, we can apply standard algorithms to solve complex issues. For example, we can find the shortest path for maximum efficiency, or use a minimum spanning tree to minimize the total construction cost. In summary, this approach allows us to use precise mathematical tools to optimize power distribution, ensuring a more reliable and cost-effective grid.
Now, I would like to talk about the tree part, the physics concept of the minimum spanning tree, or MST, and explain its engineering significance, especially in power distribution systems. As first, let's start with the definition. A spanning tree is a set graph or a connected graph that connects all nodes, contain no cycle, and uses exactly n-1 each for a node. This structure ensures that the entire network remains connected while avoiding redundant paths. A minimum spanning tree goes one step further. In addition to connecting all nodes without cycle, it also minimizes the total edge weight. These edge weights usually represent real-world parameters such as distance, construction costs, or power-related factors. Therefore, MST provides the most cost-efficient way to build a fully connected network. Yeah, and then, from an engineering perspective, the importance of MST lies in optimization. By eliminating unnecessary connections MST has reduced total infrastructure costs and keep the system structure simple and efficient. This makes it especially suitable for system-level planning in large-scale networks. And then, one important application of MST is in power distribution layout design. MST operators are commonly used to design cost-effective power line networks by minimizing total cable length and appointing redundant power lines. As a result, engineers can lower investment costs while maintaining reliable power delivery. Yes, to summarize, the key ideas of the minimum spanning tree is to connect all nodes with the lowest possible total cost. Because of this property, MST operators have strong practical value and are widely applied in power distribution network design and other engineering systems. Yeah, that's all for my introduction to the minimum spanning tree and its application in power distribution design. Yeah, in the next part, my classmate will further explain related algorithm and practical example. We will have a better understand how MSD is actually implemented in real system.
Now let's look at the execution process of cross-code algorithm. It follows 4 simple steps. First, sort by cost. We list all possible power lines and sort them from the cheapest to the most expensive. Second, select edges. We start from the top of our list and pick the lines with the absolute lowest cost. Third, avoid cycles. This is the most important part. We must check if the new line creates a loop. If it does, we skip it to avoid wasting resource. Finally, complete connection. We repeat this step until every substation is connected. This creates the minimum spanning tree. Next, why is this algorithm useful for power wiring? The main reason is global optimization. First, it guarantees cost minimization. By always picking the cheapest line first, we ensure the total construction cost is as low as possible. Second, it provides resource efficiency. Since algorithms avoid cycles, there are no redundant or extra lines. This makes the network simple and easy to maintain. This approach is perfect for planning a new power grid from scratch.
Next, I will introduce price algorithm in power line planning. In power distribution systems, electricity usually starts from the main power source, such as a substation. The network is then expanded step by step to supply power to different areas. During this process, it is important to reduce the total running costs because longer or unnecessary power lines increase construction and maintenance costs. Therefore, we need a method that can connect all power nodes with a minimum total cost. This is why price algorithm is suitable for power distribution planning. Price algorithm starts from a chosen node, which can represent the main power source. At each step, the algorithm selects the lowest cost edge that connects the current network to a new node. After adding this edge, the network becomes larger and more nodes are connected. This process is repeated until all nodes in the network are connected. In this way, price algorithm gradually build a network with minimum total cost. In this application, the power distribution system can be modeled as a graph. Each vertex represents a substation or distribution point. Each edge represents a power line between two nodes. The weight of the edge represents the cost or length of the power line. By applying price algorithm to this graph, we can find an efficient way to connect all power nodes while minimizing the total wiring cost. For a simple implementation of price algorithm, the time complexity is big O of V squared, where V is the number of nodes. Even with this simple approach, price algorithm can guarantee that all nodes are connected without forming unnecessary loops. In conclusion, price algorithm is an effective and practical method for power distribution network planning.
In the final part, we are going to summarize what we mentioned above. When comparing two computation costs, both Kruskal and Prince algorithm are efficient ways to build minimum spanning tree. Kruskal algorithm first sort all the power lines based on the cost. Because of sorting process, the complexity is E log E. This method is suitable when we want to optimize the total cost of entire power network. Prince algorithm start from a special node, such as the manpower source, the gradual spanning of network. In this basic implementation, the complexity is V2 times. It makes the suitable power distribution system that are span by span, step by step. Though these two algorithms work differently, both can efficiently define minimum cost rating plans. Therefore, minimum spanning tree algorithm is very practical of power distribution network planning. Thank you for your listening.